Okay, welcome everybody. This is block week 3. We're in August 2019. We are doing a jam-packed session, a jam-packed 3-hour package for Property Economics and Finance 1. I've summarized the whole year's work into the 6 functions of R1. We are now doing the 5th function, which is function 5, called amortization. What is amortization really? It's taking a big amount of money and breaking it up, right? That is essentially what we're doing with amortization. And we use it in reality when you go to a bank and you say, listen, Mr. Banker, I'd like to buy this house of R1 million. Will you give me this R1 million and I will pay you over 20 years? That is amortization. Amortization, quick definition, to determine the payment of an annuity. So it's an annuity, but instead of saving with the bank, you are now paying the bank, right? So it's also the vehicle, the way it's structured is also an annuity, which is several payments over a certain period at a certain interest rate, and there's a lump sum, which is either a future value or a present value, and it just the relationship between the equations is which one are we trying to determine. Okay, right. Oops, that figure is also wrong. It's supposed to, again, sorry, I apologize for that. What it's supposed to look like is you've got several payments going into the bank, and instead of a future value, you are it's a present value. So you'll find that the amortization calculation is the reverse, or it is not reverse, the reciprocal of annuities present value, right? With annuities present value, if you look at the shape of the formula, you look at the formula and you'll see you are trying to, with annuities present value, you know the payments. You knew that you can put away R100 and you're determining the amount today. With amortization, you know the value, the present value. You need to determine the payments. So like you know with a bank, there we can see it a bit better with the timeline. You'll see it's the same shape. The timeline is the same shape or the same configuration as annuities present value, right? What are we doing in annuities present value? In annuities present value, the 4th function, annuities present value, we knew that we could put away R100, right? With bank A or bank B, remember? I said you can go to ABSA, you can go to F&B. Which one are you going to choose? You knew that you can put R100 away with the one or R200 with the other, but you needed to determine the value today. With amortization, we're doing the opposite. Instead of knowing the payments, in this case, we don't know the payments. We want to know what the payments are, right? But we know that the house costs R1 million, right? How do we know this? We saw the little sign on the bank, the sign on the house. The house said the value of the house is R1 million today. So if you want this house of R1 million, you go to the bank who gives you the million, and you're going to pay the bank. These are the payments. So when you go to the bank, they're going to say, sure, take your million, but this is what you're going to pay. That's the objective of amortization, to determine the payments. Right. A quick chat about our timeline. What we've got is year 1, year 2, year 3, just show me a little break in the graph, and year 20, right? So you're showing me the timeline, so you're showing me the time frame that we're working with. You're showing me the number of payments P, which you don't know. You can put a little question mark to show you don't know what the payments are, but what you do know is the value of the house, PV, present value, in today's terms. That's what you're going to show me. The theory of amortization is it's the process of paying off a current debt over time through regular payments. What is the current debt? The value of the house, right? You want to buy that house of R1 million, and how are you going to pay it back? Through regular payments over, essentially it's mostly 20 years, right? We determine how to calculate the payments that must be made in order to redeem the existing debt. You're going into the bank today, I'd like to buy this house worth R1 million, and you're going to pay that off over a number of years through regular payments. Using a PV debt, we calculate the payments to be made over a certain period. Right. This is where everything starts falling into place. Look at the formula for the amortization. Do you see that it is the reciprocal formula for annuity's present value? Right? You must understand the relationship between annuity's present value and amortization. Annuity's present value, you knew the value of the payments, but you wanted to know the value today. Amortization, you know the value today, you want to know the payment, the payments, right? Again, so when you draw your timeline, you're going to show the little arrows going down. You've got your timeline, you're going to show the little arrows going down over the certain amount of years, and you're going to show me the big arrow on the first of today. Basically, in today's terms, you're going to show me the big arrow. Amortization, you do know the value of the PV. We're determining the payments, right? You'll see P is over here now, and present value is here. This is the 1 million, the present value that we're breaking up. That is the amount of money that we're breaking up over 20 years, right? Or the installment. Some people refer to it as an installment, but for simplicity's sake, we're keeping the we're keeping it as a P for payment. Interest again as a decimal. N for number of years. Remember, we're going to adjust for M. This formula, as is an annual formula. N is number of years. Can you see here the negative N exponent is at the bottom? In the annuity's present value, the negative N exponent was on the top, above the divide line, right? That is the formula. This is the formula that you will get on your formula sheet. It will be up to you to earn your 1 mark by adjusting the formula. I will give you the original formula. You will adjust. This must be red also, just so that you can see. You don't have to write it in red. I'm just showing it in red so that you can see, right? PV, here on top, we are adjusting our interest rate by M. If you have an old calculator, put it in brackets. Otherwise, you will not get an accurate answer. You'll mess up the formula somehow, right? Also, if you have an older calculator, you might want to put a bracket here and a bracket here, right? If you've got the older version of a calculator. And then again here, we adjusted the I by the M, and negative N times M, all in brackets. With amortization, we won't do beginning of the periods, right? We're not doing annuity, like over the present value annuity due, we had the 1 plus I. Here, we are only working with the end of the period, which makes things a bit easier. Right. Amortization examples. Consider purchasing a house today for an amount of 1 million, which is the present value. Why do you know it's a present value? Because that is the sign, that's the value on the house, right? You saw a little sign saying 1 million, present value. It's at an interest rate of 13%, which is I, compounded 12 times a year. That is your M. M is 12 times a year. M is equal to 12, right? The house will be bonded for a period of 20 years, right? N and payment P, and it will be paid in monthly installments. Again, you know that M is equal to 12. Then we'll come back to the second example in a minute. Right. Practical example, here we go. Our formula P is equal to PV multiplied by I over 1 minus 1 plus I to the minus N. Again, what do we see here? The money part of the equation. Do you see the shape even of the fifth function is the same? Money part of the equation, or the currency, whatever you like to call it, and the multiplier. What is the multiplier? The interaction of I and N. The way these two things work together within the brackets, that is your multiplier. Now, here we go. That's where we'll score our 1 mark by showing how you adjust. You adjust I by dividing by M. You adjusted I by dividing by M. You adjusted your number of years, which was 20 years, by showing 12 times per year, which is 12 times 20 years. Again, older calculators must say negative and put the bracket over there. Right, so here we go. We're going to break up this 1 million with this multiplier here. Now, look at the size of my multiplier, or the value of my multiplier. Can you see? My multiplier is 0.01171, something or other, right? the value of the multiplier is a small decimal. Do you see how the multiplier changes? Multiplier here is obviously much less than 1 because you are breaking up an amount of money. You're breaking it down. So this 1 million multiplied by this amount will give me an amount of 11,715. If I want to purchase that house of 1 million and pay it off at a 12 or 13% interest rate, compounded monthly over 20 years, my bond amounts, my monthly repayments, my installment with whoever it is, SA Home Loans, whatever, I'm going to pay the bank or SA Home Loans or whatever, 11,750 rand, 15 rand every single month. That is what the amortization objective is. Second example. Second example is you would like to purchase a car today which costs 120,000. It's also an amortization example, right? You go to a car dealer, you see the value of the car is 120,000. What is the car period? Usually 5 years roughly, right? Depending. Assume there's no deposit, right? And with the top one, assume there's no deposit. It's just full on a home loan of 1 million or a car loan with, I don't know, Santam, whoever, right? You go to Santam and you say, I'd like to buy this car of 120,000. I intend paying it back over 5 years. They've been quoted nominal, an interest rate of 12% compounded. Oh, I didn't say compounded, but I say monthly. I forgot to say monthly here, right? If it is monthly, let's see. Right, here we go. It is monthly, M is equal to 12. So, my present value, I don't know it's my present value. If I walked past the car dealership, it all had the prices of the cars in the windows, right, or on the windscreen. That 120,000, I'm going to have to break that 120,000 up into equal payments. In reality, obviously, the payments fluctuate with the interest rate, but this is just theory. So the payments are going to stay the same. Right. I listed my variables. Remember, there's a timeline somewhere there. For 1 mark, I've listed my variables. PV is equal to 120,000. I know this because I saw it on the windscreen. It's today that I'm looking for that 120,000. P is equal to question mark. I don't know. That directs me to the formula sheet. It tells me you're looking for P. Go to the formula that says P is equal to something, right? I is 12% interest rate. N is 5 years. M is equal to 12. Again, M is a number. It's 12 times per year that we are compounding, or 12 times per year that we are paying. Always the same. Paying and compounding is always the same. There we go. There's my formula. I got that from the formula sheet. Straightforward. Go to the formula sheet. Look for the right formula. Pop it in. Now, this is where I score my mark. My 1 mark for showing that I know how to adjust the original formula. The original formula is on the formula sheet. I divided by M, and they adjusted the I over here by dividing it by M. I've adjusted the period up here by saying negative N times M in the bracket if you've got an older calculator. Again, can you see I'm actually repeating myself? It's the same thing that you're doing for 6 different functions. If you follow the steps, go through the steps identically, look for the clues. What is the present value? What is the future value? What is the interest rate? How often am I compounding? I will not give you annual compounding. I will never ever give you annual compounding, which means always look for the M, the multiple compounding periods. Right, here we go. Everything in the bracket is my multiplier. I'm breaking up, amortizing that 120,000, and this is how we do it. Can you see? Money, multiplier. Money, multiplier. Here we go. There's the money, 120,000. What's my multiplier? 0.02224, right? Again, recognize the sizes or the value of that multiplier. If we go back to the 3rd and the 4th function, which was annuities, what was the multipliers? The multipliers were three figure, like in the hundreds, or in some cases, depending on the period, it can go into much bigger amounts, right? But look at the decimals, the tiny decimals. Here your multiplier is 0.0222, right? That 120,000 multiplied by the multiplier gives me an installment or a P of 2,669. So if I want that Yaris of 120,000 in the window today, I walk into the bank and say, give me 120,000 please, and I will pay you. And the banker says, sure, let me tell you how much you're going to pay. You are going to pay an amount of 2,669 in theory. So if you want to just, like I said, in reality, there's other factors. This is theory. In reality, there's going to be a different interest rate, or they're going to take into consideration all sorts of other factors. Go to an SA Home Loans website. Go to the Audi website. Go to any website that has those little financial calculators built into the website. Say, I'd like to buy the car of 120,000. I'm going to be paying over 5 years, and see what repayments it gives you. This P is your repayment or your installment. And that is some theory on amortization. Let's quickly do an example. Oh, there it is. Sorry. Right. Let's do an amortization example. Right. Here we go. Ooh, much more expensive house. Right. Amortization example. You would like to buy your dream house, which costs 5.5 million. You won't be able to conclude a cash purchase, so you approach some banks, right? So you go to 3 banks, Bank A, Bank B, Bank C, and you ask them for 5.5 million, right? And this is what they tell you, right? Bank A says, sure, you can have 5.5 million if you pay it back over 15 years, right? You're going to give us monthly payments, which is P. We're going to determine what P is. So we're going to determine what the payment is for Bank A, did I say P? What the payment here? What the P is for Bank B, and what the payment is for Bank C. Here we go. Here's the differences. Bank A says you're going to give it to us, you're going to pay us monthly installments over 15 years, and it's an interest rate of 10% compounded monthly. Bank B says, sure, you can have 5.5 million, but you're going to pay us over 20 years at an interest rate of 9.5 compounded monthly. Bank C says, sure, you can have 5.5 million, but you're going to pay us over 25 years, monthly payments as well. So M is equal to 12 for all 3 banks. And then we're going to charge you at an interest rate of 9% compounded monthly. Okay? Let's quickly go through the calculation. So do you see, it's all exactly the same operation. It's really applying the same formula. So really it's easy marks. You're just doing the same thing several times with different variables. So because of the amount of times we can change the variables, this is why we have to keep our head. In this case, I've given 5 marks. I didn't ask for the timeline, and I didn't ask you to list variables, right? So like in the exams, I'll obviously ask you, give me the timeline, list the variables, give the formula, right? In this case, I just wanted a quick answer, right? Right, here we go. Bank A, formula, calculate an answer for 5 marks. Money part of the equation. The 5.5 will stay the same, right? The 5.5 will stay the same because it's the same house that we're trying to establish payments for at different banks. Bank A, Bank B, Bank C, right? Here we go. The 10% broken up over 12, right? I adjusted the I by 12. Adjust the I over here by 12. Adjust the N over there by 12. 15 years, 12 times a year, right? Put it in brackets, calculate, look at my multiplier. So automatically, even before you get to the payment amount, you can see how the multipliers will change. Look at this. Right? So Bank A will say, for 15 years, you need to pay 59,000 every single month to have that house, to afford that house of 5.5 million, right? Multiplier is 0.010746. Bank B, formula calculate answer, the same 5.5 million, we're breaking it up, But the 9.5, you must also know instinctively you don't have to calculate it. You shouldn't have to calculate between the percentage and the decimal. But now you should just sort of straightforward give me the decimal amount. 0.095 adjusted by 12. At the bottom, 0.095 adjusted by 12. On top, 20 years, negative 20. Open your bracket always. Raise it to the exponent when you get here. Close the bracket. Raise it to the exponent, that little y to the x. Open your bracket, negative 20, not minus 20. Negative 20 times 12, close bracket, and then close bracket. You can't go wrong, right? Where we calculate, I've just showed you this so that you can trace it. In the exams, again, if you are able to go from here to here or here, it doesn't matter. If it's accurate, I'll give you the marks. If it is not accurate, you will lose. So it's basically a bit of a gamble. You need to decide how comfortable you are. If you're very comfortable, go ahead, jump from there to there, get the full marks, it's no problem. If you are uncertain, don't make a gamble. Rather give me the steps and I can see, oh, that's where they made the mistake. So I'll give the mark up here, but not for that. Just as an example, right? We're breaking up the 5.5 million. Look at the size of our multiplier, the value of our multiplier. We can already start seeing that difference, right? So Bank B is going to request 51,000 every single month from us. Bank C, here we go. Same thing. Can you see again the very, very same amount? Oh, I didn't show how I broke it up, but it is broken up as you can see. We're paying it over 25 years. Just simply populate. Again, if you're able to jump from here to here, you'll get your marks. If you're certain, go ahead and just write it in. You will get the fuller marks. Here we go. If we're paying that house over 25 years, you'll pay an amount of 46,000 per year, right? So how do we make a decision? I'll normally have a criteria. The criteria says, that's in E. If your bank advises you that you should not pay more than 50,000 per month towards your home loan based on your salary will obviously dictate what you can afford. If the bank says that you should not be paying more than 50,000 per month towards your home loan, which one will you choose? And you can make a decision. If 50,000 is your budget, you cannot afford the 59,000, so you don't go to Bank A. You won't be able to go to Bank B because you can't afford the 51,000, but you can afford with Bank C. So you'll be paying your house over 25 years, which is longer than the standard 20-year period. But in order to get that 5.5 million house, you're willing to put 46,000 down every single month. And that's how you make your decision. Let's see if we can maybe let's just recap quickly. 2-minute recap. Here we go. So we spoke about the sinking fund. What did we do in, oh sorry, not the sinking fund, sorry, amortization. There we are. Function 5, amortization. Quick debrief, we broke up an amount of money to determine, we knew what the present value is. We broke up the amount of money, which is what amortization does, and we were able to understand the installment amounts. Here we go, that's our timeline. Our timeline, the configuration or the shape of our timeline, the layout of our timeline is identical, in fact, to the timeline for annuities present value. Then again, we go to the formula, look at the formula, look on your formula sheet, compare the formula for annuities present value, look at the formula for amortization. You'll see that it is a reciprocal formula, because in the one, annuities present value, you knew what the payments were, you were trying to determine the present value. With amortization, you don't know what the payments are, but you do know the present value. That is the cost of the house, the cost of the car, the amount of money of the loan that you want to break up. And that is it. Thank you. That's the end of session 5, amortization. In the next session, the last session, session 6, we're going to do the final function 6, which is the sinking fund. Thank you.